دكتور
Yes, yes.
ما فهمت ليه عم تحكي بconvection إذا عم نحكي بثيكنس وconductivity إنه مش هون حالة conduction؟
Okay. Look, whenever here, what do you want to find? You want to find the overall U value. Okay. So what you have here, when you have your envelope, your building envelope is formed of several layers. Okay. Now, when heat will go from the outer to the inner side, when going from the outer to the inner side, you have at the outer side first you have a convective heat. Okay, so when you want to write your heat equation, what you will write, you will write that at steady state condition the heat of convection, okay, from the outer side is equal to the heat of conduction through the envelope, okay, which will be equal to the conductive heat through the first material, then through the second one, the third and the fourth one, and
equal.
finally you have it's equal to the convective heat flux in the inner side. So it's like an electricity having, if you want, if you do the analogy, it's like having resistances in series from the
بس هن بعضهم مش equilibrium. بس هن
نعم.
بعضهم مش at equilibrium. بس هن
احنا
بعضهم مش at equilibrium. ليه بدهم يكونوا قد بعض؟
لا look، شو قصدك باكويليبريوم؟ وقت نحكي equilibrium مش يعني الاوتر temperature equal للinner temperature مهدي. It's Mahdi.
Yes.
Okay. Because Mahdi here, when you say steady state condition, this means that you have the outer temperature that is not changing and the inner temperature that is not changing. This means a steady state condition. مش يعني إنه you have equal temperature everywhere. If you have equal temperature everywhere, you will not have heat transfer. But in general, when we calculate U value, we consider that we are doing the analysis in steady state conditions. So if I have a certain difference in temperature from the outer to the inner side, what will happen is that the heat flux first from the outer side to, if you want, the external surface, the type of heat exchange is by convection. Okay. Now this transfer will continue inside the material through which type of heat? Through conduction.
Conduction.
Okay. And at the end, when you reach the inner side, then to transfer this heat, you will transfer it by convection.
Oh, okay. Convection.
Yeah.
Okay.
So
Thank you.
you can do the electrical analogy of having several resistances in series. You have the resistance first here due to convection transfer. Then you have resistance inside your material due to conductive transfer. And at the end, you have the resistance due to also convective transfer. Now, for each process, you can calculate the resistance in a different way. Yani for the case of convection, okay, the resistance is 1 over the convective coefficient. Why? Because look, in general, the form of a Q, okay, let's say for convection, what is Q? Q is H times area times delta T, okay? U is what? U is, if you want a coefficient, in a way that if I give you the coefficient, you say that the total transfer is equal to the U value times the area times times delta T. Okay? So here, if you want to compare to know what is the U value in convection the U value is equivalent to H. Okay? Is equivalent to the convective coefficient. And since the resistance is 1 over U, so in convection, the resistance is equivalent to 1 over H. On the other hand, for conduction, how you express your flux of conduction? Q dot. So here also it's Q dot, yani derivative of Q with respect to time. Q dot in conduction now is equal to K times times A. So let us put A here, times minus dt by dx, which is, if you want delta t, instead of minus dt by dx, I will put delta t over the thickness over L. So if you do comparison with the form of U times A times delta t, The equivalent U value in conduction is what?
K over L.
It's K over L, because if you compare here, A will be simplified from both sides. Delta T will be simplified from both sides. So you will end up that the U value, the equivalent U value in conduction is K over L. And since resistance is 1 over U, then the equivalent resistance in conduction, so R conduction is 1 over U is equal to L over K. Okay, this is why here, whenever you have in a problem a convective process, the equivalent resistance will be 1 over H. So for the outer side, you do 1 over outer convective coefficient. Now in the 4 layers, you have conduction transfer. So for any conductive process, the resistance is equivalent to L over K. So you perform your calculation for each layer. Okay, you obtain the equivalent resistance. And finally, from the inner side, the equivalent resistance is 1 over Hi. And now if you do the analogy in electricity, if you have several resistances in series, so here if you want the current in electricity is equivalent to the heat flux, because here you have an equal heat flux that is going over these resistances, which is equivalent in electricity to having resistances in series with common current. Okay, so from here the analogy is to find the total resistance is to do the summation of all resistances calculated, and once you get your total resistance, then you can find your overall U value by saying that my overall U value is 1 over the overall resistance, so I get the value of U. And what is the importance of getting the overall coefficient? Once you have the overall coefficient, you can calculate simply. So now you can say that Q dot from between inner and outer side. So Q dot is equal to overall U overall times A times, what will be delta T here? It will be T, let's say it will be the highest T, so T out, let's say T outer is higher than T inner, so T out minus T in. Okay, so once you calculate your overall transfer coefficient, you just need to apply this formula to get what is the value of the transfer rate from outer to inner side. Okay. Is this clear? If you want, what is the electrical analogy? The temperature is equivalent to what in electricity? Who can tell me?
Current.
Doctor, why did we include the area in the formula?
Because if you don't include the area, you will get the result in watt per meter square. Okay? If you want to have your value in watt, you should multiply by the area. Because look, what is the unit of U? The unit of U is watt per meter square Kelvin. So if you want to obtain Q in watt, you should multiply by A times delta T. If you just want to find the flux per unit area, you just do U times delta T without A. Okay? So if you don't multiply by A, the unit will be in watt per meter square. Okay. Now,
but here A is only canceling out in the equation.
Yes, exactly. So if you want just, if they, depending on what they are asking you, if they are asking you for the rate, it means in watt, you should multiply by the cross-sectional area. So here they will give you then the width of your envelope. Okay, so they will give you, let's say, a wall with a width equal to 2 meters, for example, and a length of 3 meters. So you can calculate the area. Now, in case they ask for the flux per unit area, you don't need to multiply by it. Okay. Now, if we do a small analogy between heat transfer and electricity, the temperature is equivalent to what in electricity?
The current.
No, to the voltage. Because look, the current is, look how you should think here. What is constant from the outer side to the inner side is the flux. So the current is equivalent to the flux per unit area, while the voltage is equivalent to the temperature. Because if you have several resistances in series, okay? So now we are comparing, yani we are doing the analogy of several resistances in series. Then let's say this is point, outer point, this is the inner point. So in electricity, T out will correspond to the voltage at point, let's say 0.1, and Tn is the voltage at 0.2. Okay, and since you have your resistances in series, then the current which will go through the resistances is constant. So this is I. Okay. So now if you want to write the electricity equation, what is the electricity equation? The electricity equation is V1 minus V2 is equal to the current I times the total resistance, which is, let's say, R1. Let's say we have 3 resistances, for example. So it's R1 plus R2,
R2 plus
R3,
R3.
or we can say it's R equivalent if you want. Okay, so it's equal to I times R equivalent. Let us compare with what we found together. Okay, now we said by analogy U is 1 over R. Okay, so here if we replace by analogy V by T, we'll get that T out minus Tn equals to I represent in our case the flux per unit area. Okay, so I will call it Q, small q. I mean, it's a flux per unit area, small q dot if you want. Now I will put the point. So it's small q dot times, what is the resistance? In our case, it's 1 over U. So it's times 1 over U. Okay, so now I am back to the definition of the overall U value, because by definition, Q per unit area, which is in watt per meter square, can be calculated as U times delta T. Okay, so here, this is why from the electrical analogy, I can say that I can do the summation of resistances to find R equivalent, and then U is 1 over R. Okay, is this clear? Any question on this?
Clear.
Okay. So
Thank
guys,
you.
now for this week, as usual, I will now put the names of the new videos to look at. Okay, and as usual, in the next session, I will answer your questions, and hopefully we can start chapter 3 to give you an assignment to do it together. Okay.
Thank you, doctor.
Are you
So
finding the
chapter 2 is not
content?
over yet.
Are you what? No, we still have a small part in this chapter. Just a small part, some problems, and just some problems.
Ah, okay.
So this week, the videos will include chapters 3. Okay.
Okay.
Okay, guys. So, and feel free to text me whenever you face a problem. Okay. Yeah. Let's see you next time.
Thank you so much.
Doctor,
Yes.
can I ask you a question about the project?
Yes, of course. Tell me.
We chose the subject of wave energy,
Yeah.
and we found out there is multiple kind of energy in the ocean, like tidal energy. Wanted to see if we can also talk about tidal energy,
Yes,
with wave energy.
Yes, of course you can.
Oh, okay. We want to see if it would be something nice to put an economical and environmental impact
Yes,
study
of
with.
course, of course.
Ah, it's okay. Okay.
Yes,
Okay. Thank you.
welcome. So your project is going fine?
Yes, we're working on it.
Okay. هلا, look,
Yes.
we said that the deadline was March 1, but in case you feel you need extra time, little bit, it's not a big deal. So I can extend 1 week for you, but try to hurry up a little bit with the project, okay?
Okay. Thank you.
Any other question? Okay, see you next time. Bye bye.